Hello, everybody. This is Mr. Brooks, and this is the video recording for Thursday, January 20th. And I'm going to go over two things. I'm going to go over one of the Delta Math assignments, and I'm going to go over the Learning Target literal equations. Okay. So I wish I would have taken time to talk about this, but there's one assignment on here that probably needs to be talked about a little bit just to set you guys up for success. And it's this one right here. And it's going to give you an equation with x on both sides. And when you have an equation with x on both sides, one of three things is going to happen. Okay, so there's three possible outcomes. So the first thing that could happen is you have one solution, and that's what you do a lot. A lot of the times you have one solution. Okay, and then another outcome that could happen is you could have no solutions. And then the third thing that could happen is you could have what's called infinite solutions, which basically means that anything works, any number will work and the equation will be true. Okay, so you're going to have one of three things happen. How do you know? Well, if you have different number of x's on both sides, so different number of x's on both sides, then you have one solution. And basically, if you have some number of x's on the left and then a different number of x's on the right, then you're going to be able to get all the x's on one side and you'll have x equals some number. And that's one solution, right? Now, just to clarify, if you have like 7x plus 1 on the left, and then you have like 3x minus 6 on the right. Okay, this is what I mean by different number of x's. You have 7 on the left and 3 on the right. I don't mean you have one x you can see and one x you can see. That's not at all what I'm trying to say. Okay, so this would be an example of a different number of x's on each side. This would have one solution. All right. All right. So no solutions is same number of x's. Actually, they're both. If you have no solution or infinite solutions, you have same number of x's. So this would be like 3x equals 3x. So there's 3 on the left, 3 on the right. And when you have the same number like this, then you have infinite solutions because it doesn't matter what you plug in, then you get the same value on the left and the right, right? And so no solutions, well, infinite solutions would be same constants. So the same. So for example, 3x equals 3x, the constants are 0, but you can have like 4 and 4, and you still have same constants, so it'd be infinite number of solutions, right? And then now for no solution, it would be different constants. All right, so what do I mean by that? I mean, like, if you have like 3x plus 1, then you have the same 3x, but this time you have like plus 2. So the constants are different. then you can cancel the x. So minus 3x, and then you get 1 equals 2, right? And that is false. That'll never be true. And so that's why there's no solution there. Okay. All right. So this is what they're doing. So how many do I have over here? I have 1 and I have -1. Those are different. So I have one solution. And then you would have to solve. So right here, x minus 7 equals 7 minus x. So let's do plus x plus x. That's 2x. And then minus 7 plus 7 plus 7. So that's 14. So x is equal to 7. So on here, I'll do there's only one answer, and it's 7. And so when you get that, you essentially get 0 equals 0. So where did I get 0 equals 0? Well, this would be if you plug in 7 minus 7, and then this would be 7 minus 7. So it's 0 equals 0. You just plug it in. That's all you do. That's all they want you to do. And then it says a value of x that makes the equation false is you just pick a number. I mean, 7 is the right answer, so you can pick any number but 7. And since I'm plugging in numbers, I like to use small numbers. I mean, the smaller the number, the easier it is. So I'll just put 0. That would mean that if x were 0, it would be -7 equals 7, which would be false, right? So I just plug 0 in. 0 minus 7 equals 7 minus 0. And that's the way you do it. So this one, there'd be one answer, right? And the answer is 7. No, 8. 8 minus 3 is 5. And then this would be okay, so this one you distribute it and you get 4x plus 4 equals 4x plus 4. Well, what do we got? We got the same number of variables. So, and we have the same number of constants. So same variable, same constants means we have infinite solutions. So now it's 2 that mark it true, and just pick something small like 0. And if you plug 0 in, 4 times 0 plus 4 is 4, and 4 times 0 plus 4 is 4. And then you can do 1, and the 4 plus 4 is 8 equals 8. And there you go. All right, so that's how to do that. All right, so let's talk about literal equations, okay? All right, a literal equation is a lot of times you can think of it also as a formula. And we talked about in class the formula for finding the average or the mean of a set of numbers. And so a literal equation is set up where you plug different stuff in, and it has basically it has a whole bunch of letters in it, right? So here's some examples, here's some non-examples, and then here's how to do it. I mean, you can basically like move anything around the same way you would numbers. By anything, I mean if it was a letter. Okay. So the biggest thing is this you have this equation or this formula ax plus by equals c, solve for y. A lot of times you want to get y because when you get y, you get y equals mx plus b. And you guys hopefully know y equals mx plus b, or at least have heard of it. But you're not always given it in y equals mx plus b. So sometimes you're given it like ax plus by equals c. And you can plug in numbers for a, b, and c. You can have numbers for a, b, and c. You're always going to have x, always going to have y. But how do you solve for y? So we want to solve for y by itself. So we want y right here. So minus ax minus ax. So it'd be by equals c minus ax. So you see how we just use that same inverse operation? It's it's, take y and you add ax to it, so you subtract it from both sides, and then you apply like terms. You still always have to apply like terms. C is not the same as ax. A is times x, so that you can't put x and a constant together. So you have two parts. All right, and then the last thing is it's b times y, so the opposite of b times y, or y times b, is divide by b. And that solves for y. C minus ax divided by b. Okay, now you can do that with numbers also, like let's say, for example, 2x plus 4y equals 16. Okay, so maybe you're trying to solve for y equals mx plus b, solve for y. So you subtract 2x. This gives you 4y is equal to 16 minus 2x, then divide by 4. And that 16 divided by 4 is 4 minus 1/2 x. And you solve for y. So you're going to do the same thing you've been doing with inverse operations and apply it to literal equations. All right, here's some other things I always go through in class, and that's like, the formulas for life. So curiosity equals wonder plus awe. And I think that some of these are definitely worth hearing, so I go over it. Anxiety is uncertainty times powerlessness. So how do you reduce anxiety? You reduce the uncertainty, or you reduce how much you feel powerless. Happiness is gratitude divided by gratification. A little bit back more to math. Here is the first part of the 17 equations that changed the world, according to the book by Ian Stewart. You can see Pythagoras' theorem up there at the top. That's probably the most famous. Logarithms are used to undo exponential equations. Newton discovered calculus. That's just it's actually very easy. It's the change of a function subtracted by the next step of the function. How do I explain this? I can't even explain it. It's actually a very simple concept if you just hear someone explain it. But it's like the minuscule change. Like you measure the minuscule change, um, and you do that. That's what that limit goes to zero. So the limit as h goes to zero. So as this h approaches zero, you'll get closer and closer and closer and closer to a number. So there's a law of gravity. That's Isaac Newton also. He did a lot. This is Euler. Um, this is the imaginary number. You do that in algebra 2. And another Euler is the Euler's formula and the normal distribution. This is statistics. We talked about the normal distribution, the bell curve. and then a wave equation. So you can solve for any of these, you know. Oh, and then the geometric formulas. So you might say like, okay, you know the force, but you don't know, you know the gravitational constant. Well, let's just do them on delta math. Yeah, but you can move any of these around. Like you can multiply both sides of this by r squared. So multiply by r squared, r squared. So force times r squared equals gravitation, the constant times mass 1 and mass 2. Okay, and then you can, divide off g if you want to find mass 1 times mass 2. All right, so let's see. Oh, yeah, I go to delta math. Oh, I'm gonna have to log in with Google. I think 5 is the literal equations, right? Nope. 6. Okay, they start off really easy, guys. Solve the following equation for A. So where's A? Right here. So A plus F, the inverse of plus F is minus F. So minus F. So A is equal to M minus F. So A is equal to M minus F. So you see how I mean, you don't condense anything down into a number. You're just moving things around. So you have to look for what you're solving for and then use inverse operations to clear it away. Let's see, there it is right there. All right, so this one is solve for G. So this is G times J. So what's the inverse of times J? Divide by J. So this is G equals M divided by J. That's what it is. Okay, and then let's see what this. Okay, so this is the same thing. It might be 2 or 3 steps, but solve for A. So here's A right here. So what do we have to do? Well, it looks like it's basically a 2-step equation. So I would subtract Q away, right? Always add and subtract. Now, these aren't like terms. They're not like terms, and that's fine. So A divided by R is equal to N squared minus Q. And then it's A divided by R, so the opposites times R, so times R. So when you get these two parts, you'll have to use the distributive property notation with parentheses. So this is N squared minus Q times R. I think you can probably write it as R N squared minus RQ. I think you can write it like that and it'll give it to you, but I don't know. I would just leave it like this. R N squared minus Q. R and shift 6. Right? To get the exponent, you do shift 6. And that's what it is. That's solving literal equations. It literally is that. um Okay, if you get here, I didn't realize it was set up as a proportion. We're gonna do proportions next week. And this is a proportion, so ratio equals a ratio. So what you do to solve for we're gonna get to this next week. You can just hit next problem, but it's just cross multiply. Cross multiply and set them equal to each other. So Q times F is Q times F is equal to R times G is R times G. I'm solving for F, so I need to divide Q. So it's RG divided by Q. So when you see a proportion, so it's fraction equals a fraction, it's just cross multiply, set them equal to each other, and then divide. Cross multiply, divide. Some people call it the fish method, I think. So RG divided by Q. RG divided by Q. I wonder if it wants the capital Q. Probably does want the capital Q. Cross multiply, divide. Yep. All right. Good luck with everything, guys. I'll be back Friday, and do your best, and we'll see you later.